So, number one, the table below shows corresponding values of x and y for this given function here, with the values for y rounded to 3 decimal places where necessary. Okay, so we've got x values here, and we've got a table which also consists of y values. Now they've done everything but x equals 15. So let's read part A. A. Complete the table by giving the value of y corresponding to x equals 15. This is straightforward. You literally just have to replace this x value here with 15. So you, in your calculator, you can use a fraction button or any scientific calculator and write 1 over the square root of bracket 15 plus 1 and get your answer. You can actually do it mentally, and if you do, you should get 0.25. Okay, not bad. B. Use the Trapezium Rule with all the values of y from the completed table to find an approximate value of this integral. Now no guys, yeah, we never evaluate integral because this is something you do at the C3-4 level. You're not taught how to integrate this. You could actually integrate this, but you'll get no marks because they specifically tell us to use the Trapezium Rule. So what is the Trapezium Rule, yeah? Well, the Trapezium Rule tells us that this solution here will be equal to some change over x, so let's call this delta x, change over x, divided by 2 times the first and last y position, so let's call it y0 plus the last one, yl, plus 2 times everything in between, so all these values in between, so the rest of the y values between. And yeah, so now we just evaluate this. The actual formula looks a bit different. Instead of changing x, they use a h, which just means the difference in the x values. So what do we have? We can see that the change in x between each one is going up in 3s. So that's going to be our delta x, so it'll be 3 over 2. Our first y value and our last y value, so the 0th and the last, is 1 and 0.25. So just put that in. And guys, you can just put this all in your calculator. Maybe just show the working out, but full answer in the calculator. Now for the rest of the y values in between, we're talking about these lot, yeah? So literally put all of these lot in the calculator. So you can just sum them up right now. So it's going to be 0.5 plus dot 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 plus all the way up to 0.277. Close the bracket and then close the other bracket. And then simply just run it through your calculator. And when you do so, and I've done it before, you should get an answer which says exactly 6.288. Now we're gonna be careful here. It says give your answer to 2 decimal places. So 2, yeah. Here we got 3. So therefore we're gonna round this up to 6.29. Yeah, and that's one done. Okay guys, number 2. So we're given a function which is a cubic and it has a and b in it, which is unknown. Now it tells us when this function is divided by 2x minus 1, the remainder is 1. Now what this tells us exactly is that when you divide it by a linear term, it's trying to say that when you set this to 0 and you solve to find the value x, which comes out to be a half, you would plug this half into this function and it should equal to 1 because that's what the remainder would be. So let's do that right now for a second, yeah? So let's go ahead and replace all these x terms with a half. So we can say that the function at the point half is going to be a times half to the power 3, and in your calculator that's 1/8. That's so a times 1/8 is a over 8 plus, and now in your calculator just put all at once, 2 times half to the power of 2, and that's going to give us 2 times a quarter, which is a half, plus bx, so b times a half is b over 2, minus 3. And all of this, as we know, should give us a remainder of 1, so equal to 1. Now, the objective is to make this equation here look like this one here, a plus 4b equals 28. Now, we're almost there. We got an a, we got a b, we got a bunch of numbers. It looks to me you're going to get 28. But to make it nice and easy, let's go ahead and clear the fraction because there's no fraction involved. So times all of this by 8, okay? Let's do that now. So times in all this equation by 8. I'll change my pen. So a over 8 times 8 becomes just a plus times the half by an 8, you get 4 times b over 2 by 8, you get 4b. And then times, and you know what we could do? Just let's add 3 across. So 1 plus 3 is 4. And I'm multiplying 4 by 8, you should get 32. And now it's straightforward. Now we go ahead and just subtract 4 across, and therefore we'll go a plus 4b equals 28. Alright, so that's the first part done, and that was 2 marks. Yep, sounds right. Now next one, when the function is divided by x plus 1, the remainder is minus 17. So same thing applies. When you set x plus 1 to 0, you're going to plug in the value of x equals minus 1 into the original function, and the remainder, and it should equal minus 17. Find the value of a and b. Okay, so we're going to do the same thing to obtain another equation. Let's do it right now. So replacing x with x cubed with minus 1, so it's going to be, so I'm going to go down a bit. Yep, that should be okay. Okay, so part B. We're going to have minus a. Now replace minus 1 in the x squared, becomes positive 1, so 2 times 1 is plus 2. You can put this all in your calculator, just the normal numbers. Bx becomes minus b, and then minus 3, and it must equal a remainder of minus 17. So we just go ahead and tidy this up a bit. So what we could do is 2 take away 3 is minus 1. Add it across, you get minus 16. And on the left side, you got minus a and minus b. Now, just to make it look nicer, I'm going to go ahead and move minus a minus b across to the other side and minus 16 to the left. So then everything goes positive. Okay, so therefore, a plus b equals 16. Now, looking at both these equations, you can see we've got pair simultaneous equations. So what we have to do here is use your new equation here and your original equation here and just subtract them. So let's go ahead and line them up first. So the first equation was a plus 4b, and that equaled 28. Second equation, a plus b equals 16. So what I would do, I noticed that the a's are the same. Let's go ahead and subtract the whole thing, yeah? If you subtract it, the a's cancel out. 4b take away b is 3b. 28 minus 16 is 12. And then, yeah, you're done. And then now just dividing 3 across, you're going to say that b is going to equal 4. And since b is 4, use the second equation here. A plus 4 is 16, so therefore, subtracting 4, a must be 12. And yeah, guys, that's number 2 wrapped up. Okay, number 3, guys. So, the line L1 passes through the points A and B at certain x and y values, alright? Find the gradient of this line, L1. Okay, so this is straightforward, standard formula. So to find the gradient, it's just simply the change in the y coordinates over the change in x. So right here, change in y over change in x. We have 2 coordinates, we just find the difference of the y's and x. So what I'll do, I'll just say, find the difference between b and a. So you can say difference in the y would be minus 8 take away 4 over the change in x, 5 take away minus 1. So 5 minus 1. Now I wouldn't bother working in our heads. You might as well just put this in your calculator, and when you do, you get a perfect result of minus 2. And that's it, that's our gradient, minus 2. Now, part B. The line L2 is perpendicular to the line L1. So perpendicular means that the line is moving in this direction at 90 degrees. If this was L1, then this must be L2. If this was a gradient of minus 2, then the gradient here would be the negative reciprocal. So if it was minus 2, it would become a positive, and reciprocal 2 is half. So that's our new gradient, positive half. Okay, and it also passes through a point, B, 5 minus 8, which is the same point. Find an equation for L2 in that given form. Okay, so this isn't too bad. We just use the standard y equals mx plus c. So using y equals mx plus c, we just need to find m and c and then make it look like that form. So m, we know the gradient is half, so therefore y equals half x plus c. We also know it passes through a point B, so it passes at B, which is 5 and minus 8. Now the beautiful things about these y equals mx plus c equations is that all you got to do is find the value c if you know what x and y are. We know x and y are, it's 5 and minus 8. So we can say therefore, replacing the coordinates of y is minus 8 and x is 5, we're going to have an equation that looks like minus 8 equals half times 5, which is 5 over 2 plus c. And then go ahead and make c the subject. I'm going to go ahead and subtract 5 over 2 across. So therefore, c is going to equal minus 8 minus 5 over 2. Put that in your calculator and you should get something like c equals, what I get, minus 21. Nice. Now, since we got our equation, just replace that C with what you got. So therefore, our equation of line 2 equals half x minus 21 over 2. And voila, we're done. Now, just being careful, they told us to make it look like this form, where a, b, and c are integers. Right now, they're fractions. So let's go ahead and clear the fraction. And the best way to clear it, they're all over 2 times the whole lot by 2. So times this equation by 2, we're going to have 2y equals half x becomes just 1x, so x, 2 cancels out, minus 21. Now we're going to make it all equal to 0. And it's going to be x first, then y, then a constant. So x is here. I'm going to move 2y to the right. So it would be 0 equal x minus 2y minus 21. And just to be safe, equal 0 is on the right. So therefore, we're going to have x minus 2y minus 21 equals 0. So what do we have here? So given that y equals this fraction, where x is strictly positive, express each of the following in the form kx to the power n, where k and n are constants. All right. So they want us to express it in this form, y to the power minus half. Now, all this is saying, you have an expression for y. What happens if you put power of minus half on it? So essentially, it's going to be the whole expression, 64 x to the power 6 over 25, all to the power of minus a half. Well, thankfully, we have calculators here, yeah? So all you have to do is attach this power of minus half to everything. So all of this here is going to become 64 to the power of minus half, x to the power 6 times minus half. So everything goes on the power line, and 25 to the power of minus half. Well, these two results, 64 to the power of minus half and 25 to the power of minus half, you can put it in the calculator. And if you do so, you're going to get exactly 5 over 8. Now, as for the 6, you just multiply the power level. So 6 times minus a half. If you do that, you get x to the minus 3. Okay, so that's A done. Now for B, so now they wrapped up 25 to the y, all to the power 2 over 3. Okay, so same thing applies here. This time we're going to multiply this by 25. So 25 times the fraction here. Well, what happens? This 25 cancels out because 25 over 25 goes. So you're left with now 25y equals 64x to the power 6. Now you want to put all of this to the power of 2/3. So now we're going to wrap all of this up by 2/3. And that's it. So now all you want to do is essentially, like the other one, evaluate everything here. Okay, so let me just clear this out. So in our calculator, we're just going to put 64 to the power 2/3. Doing so, and I did it before, you're going to get 16. Now x to the power 6 times 2/3, so this is x. You're just going to do 6 times 2/3, and that's going to give us a 4. All right, number 5. So find the first 4 terms in ascending powers of x of the binomial expansion of the following, given each term in its simplest form. All right, so this is a straight up binomial expansion question, yeah? Now, there's a super easy method. I'm just going to show you how it's done step by step. So what we begin, so we can say for part A, the expansion, so the answer is going to equal, or about equal, because it's an estimate, because you're only going up to the first 4 terms. To do this, we start with the first term, so we write 1 plus, and then we take the second form, so it'll be x over 3 times its power. So let's start with the power first, so 18 times x over 3. And now what we have here, we've got the first and second term, so we've got 2 more terms left. Now for the next term, it's the same thing. So we use the same number, so 18, and we got 1 back. So subtract 18 from 1 is 17. So I can put them in a bracket. And because there's 2 terms here, over 2 factorial. And we copy this, the x over 3. So if this was power 1, this is going to be power of 2. And that's it. Now we got 1, 2, 3 terms. Now for the next term, it's the same thing. So it'll be 18 times 17. So always go one down, 16. There's 3 values, 3 factorial. Times x over 3 to the power of 3. And that's it, guys. Now all you do here is just simplify these calculations, yeah? I'm going to just delete this power 1 here. And to do this efficiently in your calculator, because that's the whole point here. So we've got the first term, which is 1, so that checks out. Plus, in your calculator, just ignore the x over here. So treat this as a 1. So you'd write 18 times 1 over 3. And that would give me or us 6x. So here's the next one, yeah? Again, you do the same thing here. Make sure you use the factorial button. Even though it's obvious for 2 factorial, for higher values, you don't be making that mistake. So in your calculator, write all of this again, replacing x with 1, so it'd be 18 times 17 over 2 factorial times 1 over 3, all brackets squared. Doing so, you should get 17x squared. And lastly, repeat the same for the last term, and you'll get a fraction answer this time, which would be 272 over 9x to the power of 3. And that's it, guys. That's A done. Okay, so all of this is straightforward. Use the straightforward method and it works. Okay, next one, part B, yeah? So using the answer to part A, so our estimate equation right here, to find an estimate value for 31 over 30 to the power 18, stating the value x that you have used and shown you're working, give you estimate of 4 decimal places. Alright, it's a little tongue twister. So looking at both of these expressions, what they're trying to say, if we can match the fractional term 1 plus x over 3 with 31 over 30 to find the value x, we can use that x to plug into this equation and get an answer. That's the simple way. So what we can say, these two are the same when 1 plus x over 3 is 31 over 30. Now, in order to get x, all we could do is simply subtract 1 across and then multiply by 3. And when you do that, you'll get an x value of 1 because it's more convenient. Now, according to the question, it says stating a value of x, which we just did, should give you an estimate of 4 decimal places. So we're going to estimate this value using our x value. So all you have to do, replace all of this x's here with 0.1. So to show you working out, always do this in your exams. You're going to write 1 plus 6 times 0.1 plus 17 times 0.1 squared and so on, yeah? I recommend you do that just in case they might drop you marks for not actually showing it, yeah? And when you put this in a calculator, and you get an answer to 4 decimal place of roughly 1.8002. And that's it, guys. This question is wrapped up. Okay, guys, number 6. So here we need to find the exact values of x for which this log equation equals 2. All right? Give your answers as simplified surds. Ooh, all right. So to solve this kind of a log equation, we just need to know some log properties. So let's have a look at it. So the general log rules, I'm going to write 2 of them here. One that involves this multiplication bit, 2 times the log, and another one that involves subtracting logs. So if you got something like n times a log, let's ignore the base 5 here, log a we call it, that's the same as writing log a to the power of n. Okay, so these are identical expressions, and we're going to apply that. Now, if you're subtracting logs, let's say we got log a minus log b. This is the same as saying log a divided by b. So this uses the division rule. And likewise, if you're adding logs, it will be log a times log b, log a b. So log a times b. Oh my god. Okay, so that's really it. Now let's apply these rules to the question, yeah? So in this case, we've got 2 times the log, so this becomes a power. So let's put a line here. This means from the question, we got log, don't worry about the base 5 for a second. So log base 5, x plus 5, the 2 becomes a power here. Then we put minus log 5 2x plus 2 equals 2. So just copy the rest. Now, using the subtraction law, if you subtract, you end up dividing the terms in log. So therefore, we're going to have a log 5 inside a big bracket, so a over b, be x plus 5 squared over 2x plus 2. Now all of this is going to equal, of course, the right hand side, which is 2. Now what do we do from here? So now there's like another property, and it's called the log ladder method, or at least I made up. So the rule is that we want to try and eliminate the log. Now the nice way to eliminate it is to firstly hold this fixed, and then using the ladder rule, this 5 goes up a level and this 2 goes up a level. So the equation becomes the inside bit, so x plus 5 squared over 2x plus 2 equals 5 goes up and this 2 goes up as well, and that's it. That's the transformation, yeah? So the general rule is, if you had the log a, let's say log a b equals x, we hold b fixed, so it'll be b equals a to the power of x, so it uses the step rule. B stays fixed, A goes up a level, X goes up a level. Okay, so now we're almost done actually. So now this is just a case of solving this simple fraction equation. So let me just move my face over there. So what can we do here? Well, I guess we can times 2x plus 2 across. And oh yeah, 5 squared is 25. So we can say we've got x plus 5 squared equals 25 times 2x plus 2. Let's go ahead and expand both sides of the brackets, yeah? So x plus 5 squared, that's just literally x plus 5 times x plus 5. I'm going to assume you guys are comfortable with it. When you multiply out, you're going to get x squared plus 10x plus 25 equals. And on the right side, 25 times everything aside gives us 50x plus 50. Okay, so now we see something. We can see that we're producing a quadratic equation, yeah? So we've got an x squared term, a regular x term, and a number term. Let's throw everything on the other side, yeah? So I'm going to move this 50x and this 50 to the left. And to do that, we need to subtract them, yeah? So minus 50x across, 10x, take away 50x, gives us minus 40x. Subtracting 50, 25 take away 50 is minus 25. And that's it, we're almost done. Now, after all these steps, what they really want is a simplified surd for the value of x, yeah? So let's try and give them that, yeah? So, since we got a quadratic equation, we could use a quadratic formula. You could also complete the squares another way, but let's stick to the formula because that way we'll get it right. So let's say x equals a quadratic formula, which is minus b plus minus the square root of b squared minus 4ac all over 2a. Alright, and we're almost done. Now we're going to replace every term. So what is a, b, and c? Well, a is the first term of the x squared, so if there's no value, it means 1, so a is 1. B is the x terms, the value from the x terms would be minus 40. So this from, and c would be the minus 25. So now we're just going to substitute this in, so make sure you substitute in carefully, guys, yeah? Notice one thing, this is a minus b. And since b is negative, minus b would be positive, so it would be 40 plus minus b squared would be minus 40 squared, or you can just write 40 squared, because squaring a negative is positive, but let's keep it like that. Minus 4 times 1 times minus 25. Quick tip, guys, yeah? Keep everything in a bracket when you replace letters, so that way you don't make any simple mistakes. Over 2 times a, 2 times 1. And that's it. Now putting this in your calculator, and you should get two answers. First, you put the plus and the minus, or you get the same answer. You're going to get x equals 20 plus or minus 5 root 7. And that's it, guys. This question is done. So a sequence is defined by the following. So what it says here is that the first term u1 equals 3, and then we got some sort of recurrence where the next term equals the previous term minus 5. So that's what n plus 1 means. It just means the next term after n. So if it was u2 here, it must be u1 there, u3, and then u2 there, and so on. Okay, in the question, it wants us to find the values of the next three terms, u2, u3, and u4. Alright, let's do it. So to find u2, we're just going to plug in u1 back. And since we know that u1 equals 3, it's going to be 3 minus 5. And that's it, that's just going to be minus 2. So that's our u2 value. And then for the next one, u3, we plug in u2 back in, so minus 2, and then follow the sequence, minus 5. That's going to give us minus 7. And as you can see, doing the same for u4, you plug in u3 back in, so it'll be minus 7, and then subtract 5 will give us minus 12. That's it, guys. That's A done. Now for part B, it uses a slightly different trick here. To find the value u100, well, let's go back to some of the formulas we know. We know that for an arithmetic series, let's say un, it's always going to be the first term a plus n minus 1 times a common difference d. Okay, so this is a standard formula. We want to find u100. So this is going to be the 100th term equals the first term. And now what you should realize from this, like, what is the first term in this case? It's going to be the sequence from u1. So if we imagine what we just found, so we found the u1 value, and then u2, u3, and then finally u4. We can see that the first term is 3, and then there seems to be a common difference of minus 5, because it's going down by minus 5. So in this case, we say a is 3, d is minus 5. Plug this back in, so you can get 3 plus, and then n is 100. 100 take away 1 is 99 times minus 5. And then putting this in your calculator, you should get a value of minus 492. That's it, that's B done. Now the last one is part C. So they want us to find the sum, so that notation means sum, from the first term all the way to 100. So essentially you're trying to find the value of u1 plus u2 plus ... all the way up to u100. Now to do this, you could just use the summation formula, because in arithmetic series we know about the Sn rule, where Sn equals n over 2 times a plus n minus 1 times your common difference d. Now plugging in all the values we know a is 3, d is minus 5. In this case n is 100, so we should get 100 over 2, 2a is 6 plus 99 times minus 5. Basically plug this all in and you should get a final result of in your calculator minus 24,450. And that's it guys, that's 7 done. Okay, number 8. So the quadratic equation, which is this bit here, where k is a constant, has no real roots. Okay, when something has no real roots, this implies that the discriminant, b squared minus 4ac, must be negative. Okay, this literally tells us that when you plot a u-shaped graph, it does not touch the x-axis. If it did touch the x-axis, then you would have a real root. If it goes through at 2 points, then you have 2 real roots. Okay, so let's keep going. A, show that k satisfies this inequality. Alright then, so what you literally have to do, so we start from the no real roots part, and we're just going to substitute the value of a, b, c into this equation here. The values of a, b, c correspond to this part, the b part here, and the constant c. So a is going to be k minus 4, b will be minus 4, and c is going to be k minus 2. So let's plug it in then, yeah? So the b squared is going to be minus 4 squared, which is just 16, minus 4 times the a part, which is k minus 4, and c is going to be k minus 2. And because it has no roots, it's going to be negative. Right, so what we're going to do now is just expand this to the best we can. So let's do this here. So we're going to have 16 minus 4. So let's go expand the quadratic bit here. So we're going to have k times k is k squared, k times minus 2 is minus 2k, but then minus 4k combined makes it minus 6k. Lastly, minus 4 times minus 2 is plus 8, and that's less than 0. Alright, so the next bit now, let's expand the bracket further. We're going to have 16 minus 4k squared plus 24k, and then this one minus 4 times 8 is minus 32. Now let's just tidy this up. So notice how the sign is greater, and you can see k squared is positive, so they probably moved everything to the right side, yeah? Let's do that right now, yeah? But before that, actually let's tidy up first. So you got 16 take away 32, which is minus 16, and then minus 4k squared plus 24k less than 0. So moving it to the right hand side, we're going to have 0 less than, and put this in order, 4k squared minus 24k plus 16. And just for the sake of it, let's just put the greater than 0 on the other side, yeah? So it'll be greater than 0. Now to see what they got, well, they actually fully simplified it. It looks to me like they divided the whole expression by 4. So let's divide it by 4, yeah? Doing so, we're going to therefore get k squared minus 6k plus 4. And we're done. So that's A done, guys. Now for part B, we have to find the exact range of possible values of k. So this is literally telling us to solve this equation now and find what k could be. So because it's a quadratic, let's use a quadratic formula and solve this, yeah? So doing so, we can say, we can just pretend this equation equals 0 as well. So let's use the quadratic formula. We can say that k equals minus b plus minus the square root of b squared minus 4ac over, 2a. Now in this case, our a value is going to be the coefficient here, which is 1 in front of k squared. B is going to be minus 6, which is this bit, and c is going to be plus 4. Okay, so when you substitute all this in the calculator, guys, by the way, you're going to get something like this, and because I already done it, I actually got 3 plus minus root 5. Now to be sure, you know, just do the plus, for example, and it should come out as your calculator as 3 plus root 5. If you put the negative sign, you're going to get 3 minus root 5. So you can collectively write this. Now, since we got this is known as the critical value, yeah? So what that means is that this is literally, we're going to find out whether k is going to be bigger than one of them or less than other. But to be absolutely clear, let's plot this on a graph, yeah? So we always plot a graph. Let's call this side k, and then whatever this is, let's just call it a function of k, yeah? We're going to have the roots, 3 plus root 5, 3 minus root 5. Let's just say 3 minus root 5 is here and plus root 5 is there. So it'll be a nice U shape. Now, because the graph, what do we know about the expression? Because we know that the equation is greater than 0, this means that for the equation to be greater than 0, it has to be above the y-axis. So it has to be from here. The line goes above the y-axis at these points. And just remember, this is 3 plus root 5 and this is 3 minus root 5. So therefore, we could say that the possible ranges of values of k is going to be greater than this quantity. So k would be greater than 3 plus root 5, or k is going to be on this side, less than 3 minus root 5. So k is less than 3 minus root 5. And that's it, guys. This would be number 8 done. Okay, number 9. So a cyclist aims to travel a total of 12 kilometers over a number of days. We know that he cycles 12 kilometers on the first day. He then increases the distance that he cycles each day by 6% of the distance cycled on the previous day until he gets to 1200 kilometers. Now, so what this is trying to say is that we have a geometric sequence where on the first day, which is A, he travels 12 kilometers, and then that the common ratio is that it increases by 6%. So it's not going to be 6%, it's an increase, so it'll be 1.06. If it was a decrease, it would be 1 minus 6%, which would have been 0.94. So in this case, this is what we have. And he's going to keep on doing this until he gets to a final distance of 1200. Okay, cool. Now A, show that on day 8, he cycles approximately 18 kilometers. Okay, so before we do this, let's look at some general formulas, yeah? For any given day, we need to know that the general formula, which is UN, is going to be A, the first day, times the common ratio to the power of n minus 1. Alright, so this is the key thing. Now we're trying to find the 8th day here. So it's going to be U8. That's going to be equal to A, which is 12, times the common ratio, which is 1.06, to the power of n minus 1. So 8 take away 1, which is 7. And when you calculate this, you should get something like 18.04. And as you can see, that's approximately 18 kilometers. Okay, great. So that's 3 marks for that. Now, next one. He reaches his total of 1200 kilometers. So this is total, yeah? So this will be the sum on day n, where n is a positive integer. Find the value of this n. Alright? So to do it, let's record the other formula, which is the sum, the geometric sum. And this is equivalent to A times 1 minus the common ratio to the power of n over 1 minus the common ratio. So this formula, I think it's best you just memorize these formulas because you're going to use them all the time. Now, all you want to do is literally just plug in all the values. And oh yeah, the total has to equal 1200. So that's another key thing. So literally, you're going to end up solving an equation that looks like that. Now, updating your values, yeah? So we've got A, which is 12, and R is 1.06. We're going to have 12 times 1 minus 1.06 to the power of n over 1 minus r, which is minus 0.06. All of it equal to 1200. Now at this stage, you just want to go ahead and solve for n. So what we could do, we can just put in our calculator right now, 12 over minus 0.06, and then using the answer, put 1200 divided by that. And you should be left with something like 1 minus 1.06 power n equals to minus 6 on the right side. Now just rearranging this, so I'm going to add 6 across and plus this term to the right. We're going to get 7 equals 1.06 to the power n. Okay, so now looks all good so far. But the next thing is to somehow work out that value n. So what I would personally recommend, just take logs, yeah? If you take logs, it will drop the n down to the ground. So let's do it. We're going to have now log of 7 equals the log of 1.06 to the power n. And from here, n becomes a term in front. So it'll be n times log 1.06 equal to log 7. And finally, just divide log 1.06 across, so you're going to have log 7 over log 1.06, and it should equal n. And in your calculator, you're going to get approximately, what is it, 33.395 ... which is, and what it says here, you want to find a positive integer. Because this counts as days, this is like saying 33.39 days. And you're basically on the next day, so this is more or less the 34th day, but early on. So you're on the 34th day. And that's it, so n is 34. Okay, part C. So the cyclist stops when he reaches 1200 kilometers. Okay, and we know that that's exactly at time n. Find the distance that he cycles on day n, giving your answer to the nearest kilometers. Ooh, interesting. So what do we know? So we know that exactly at this point in time, so on the 33.395th day, he traveled exactly 1200 kilometers. So let's just ignore this 34th day for a moment, yeah? Let's work with this decimal. If we make a little timeline, let's say from here all the way to the end, and just label this 1200 kilometers, we can see that for the first 33 days, which we were able to compute, by the way, plus this extra little decimal day, 0.395, this will give us a total of 1200 kilometers. Okay, so now we just need to compute S33. So what does that give us? Well, using the general sum formula, it's going to be a times 1 minus r to the 33 over 1 minus r. And we know what a and r is. A again was 12, r was 1.06. If you plug it all in here, you should get a distance of 1,168 kilometers. Yeah, so that's how much he traveled in the first 33 days. So technically, if he stopped at 1,200 kilometers at some point in the 34th day, like early on in the day, that means for the remaining distance, if you subtract 1,200 from S33 from this result, we should get that small distance of 32 kilometers. And that's it, guys. That's literally how much he traveled on day 34. So figure 1 shows a semicircle with center O and radius 3. Okay, so if you got a center O and you know the radius, this means every straight line coming off it must have the same radius of 3. So this will be 3, and then this line will also be 3. Okay, next. So XY is the diameter of the semicircle, so that just proves it. The point Z is on the circumference such that angle XOZ is 1.3 radians. Yep, we see that. The shaded region enclosed by the chord, arc, and diameter is a template for a badge. So just quick recap. This line is a chord, so it does not pass through the center. This part of the semicircle, i.e. this part, is an arc, and the diameter is just a line cutting through from X to Y. Okay, so it's twice the radius. So let's move on to the actual questions. Now, find, given each answer the 3 similar figures, the length of the chord XZ. Alright, let's work out the length of this line. So, easy way to do this, let's just pull out this shape for a second, yeah? So anything relevant to it. So from here, we can see that we have a nice simple triangle with length 3, angle 1.3 radians, and we're trying to determine this length here. So let's call it x, small x. Now, look at this carefully. So basically with these kind of questions, we need to determine what kind of triangle formula we're using. Well, it's either going to be the sine or cosine rule. Now, to know which one to use, you should always use the cosine rule if you're dealing with 3 lengths and an angle. Otherwise, use the sine rule. So in this case, we've got 3 lengths and an angle. Let's use the cosine rule. Now, the cosine rule formula is actually like this. We have an a squared, which must be equal to b squared plus c squared minus 2bc cos a. Now notice how you only got a single angle here, which is capital A. So what we do, because we've got 1.3 radians, this will have to be automatically labeled as A. That means the length opposite angle is small a. That means B and C would be the 3's. So let's go ahead and update this formula. So replacing little a with x, we've got x squared equals 3 squared plus 3 squared minus 2 times 3 cos 1.3. Now notice how all of this nicely equals x squared. So all we do now is literally smash this in the calculator. Now before you do that, make sure your calculator is set in radian mode, not degree mode, yeah? Otherwise your answer will look kind of messed up. Once you get the answer of this, to find x, we just square root the result. And then when you square root the result, you should have an answer which is approximately 3.63 centimeters. Because remember, they want answers in 3 significant figures. Okay? Alright, perfect. That checks out. So now let's look at part B. So here they want to find the perimeter of the template XZYX. So in other words, we start from X up to Z, all the way down to Y, and then back to Z. Okay? So what do we know? So looking at this across, well, we just determined the length of XZ. It was what? 3.63. We have 3 here. We have 3 ready. So technically, we just need to work out what this arc length is. So let's go ahead and pull out this shape for a second, yeah? So, oh yeah, one thing to notice. Notice how we don't have an angle here. Now, to work out an angle, at least on a straight line, we know generally from degrees that all angles on a straight line must add up to 180 degrees. So when it comes to radians, all angles on a straight line must add up to pi radians. Okay, so remember, pi equals 180 degrees. So if this is 1.3, then this value here will be pi minus 1.3. Okay, so we can put on a calculator, you can simplify that. But just for demonstration, I'll leave it like that. So, okay, so here's our value of angle. It's going to be pi minus 1.3. Therefore, to work out the length of this arc, well, the arc length is so easy. It's literally the radius times your angle, theta. So, r theta. So, since we know the angle is pi minus 1.3, we know the radius is 3. So, it's just going to be 3 times pi minus 1.3. And when you do that, so I'm just going to write down here. So the length of the arc is going to be radius times the length, the angle, pi minus 1.3. So therefore, so whatever this gives you in a calculator, just put that in and add it to 3.63 and 3 and 3, and you should get a total perimeter of roughly 15.2 centimeters. Okay. Okay, part C. So now we need to work out the area of the template. Well, as you can see, the template here is made up of a triangle and a sector. So naturally, all you need to do is work out the area of this triangle first and add it to the area of this sector here, and done. You got the answer. So what is the area of a triangle formula and area of a sector? Well, the general formula for a triangle is always half AB sine C, where C is the angle between A and B. So looking back here, so let me just put a little triangle here. So look at this triangle. Since we know that the angle is 1.3, the lengths between angle is going to be 3 and also 3. So that's it. So this is going to equal half times 3 sine of the angle, which is 1.3 radians. And now for the area of a sector, it's always going to be half r squared theta. Okay, where theta is the angle and r is the radius. So looking at our sector equation here, so our sector is this bit. Well, we can see that the angle we found before was pi minus 1.3, and the radius is, well, 3. So it's going to be half times 3 squared times pi minus 1.3. So in your case, if you already worked out this angle, well, just replace that instead. And then finally, to work out the total area, the area of the, the template, just add them both up. And when you add both of these up in a calculator, you should get a final answer of 12.6 centimeter squared. Alright guys, number 11. So the curve C has equation y equals fx for positive values x, where the first derivative, so this notation means when fx is being differentiated, equals this following equation. It is given that the point P at x when x is 4 and y is 14 lies on this curve C. Right, so we're given some few critical informations, yeah? By the way, when you have an equation like this, the first derivative, this is actually known as the gradient equation. So the y equals fx is the y equation. This is known as the gradient equation. Okay, let's look at part A. So find fx, right, in each term in simplified form. Alright, so it looks to me that you want to go from this equation and just integrate back into the regular fx. So let's try this out. But okay, before we integrate, we need to firstly rewrite this into its correct indice form, because you can't integrate something like that. It's a bit complicated. So how do we do it? Well, let's try and tidy up this fraction, yeah, and simplify it. So what do we have? So you can say that this derivative equation is equal to 5x squared over 2 root x plus 4 over 2 root x. So remember, distribute 2 root x to both, minus 5. So looking at both of these head on, 5 over 2 is just literally 2.5, or you can leave it as a fraction. x squared over root x. Well, we need to know that root x is the same as x to the power of a half. Okay, so therefore, when you got x squared divided by x power half, when you're dividing terms, you subtract the powers. So 2 take away half, it's going to be 3 over 2 or 1.5. So because we're using a calculator, we can use decimal. It's all good. Now plus, you got 4 divided by 2 is just 2. And now this is, again, x power half. But because it's 1 over and you bring it to the baseline, it'll be x to the negative half. Okay, or negative 0.5. And then therefore, and you also got minus 5. So here we go. So this is so far the equation of f prime x equals that. Now, let's go ahead and find the integrator, find fx, yeah? So we can say, therefore, for a, fx is the solution after you integrate this term. So integrating this, we're going to have 2.5x. So integrating, you simply add 1 to the power. So it'll be 1.5 add 1, which is 2.5, and then divided by itself over 2.5 plus 2x and add 1 to minus half, which is going to give you plus half, so 0.5 over 0.5. And lastly, if you got no term, you just add an x. And finally, one thing we must never forget is the constant of integration plus c. Because if you're integrating 0, you'll be left with a constant c. So that's what we got so far. Now, oh yeah, find fx writing each term in simplified form. So let's go ahead and simplify what we got, yeah? So 2.5 over 2.5 cancels out. You're left with x to the power of 2.5 plus 2 over 0.5 is 4. If you're not sure sometimes, just put in the calculator, 2 divided by 0.5. And then 0 power 0.5 minus 5x plus c. Alright, so far so good. Now, just a quick note here, this c is not the same as that letter c, yeah? Even though it looks the same, they're not meant to mean the same thing. This is the constant integration. That's just what they label the curve. So to find this value c, they give us a little hint. They say it is given at the point P lies on C. So it's trying to imply that when x is 4 and y is 14, in other words, when fx is 14 and x is 4, you can substitute them in and rewrite to find the value of c. So let's try this out here. So we can say, all right, replacing fx with 14, replacing x values with 4, because that's what it is. We can now literally rearrange the solve for c, yeah? So let's have a go, guys. All right. So what I would do is firstly, just literally put this all in the calculator. Whatever that gives you, in your calculator, you're going to write 14 minus that answer, and it'll give you that c value. Okay? And therefore, when you do this, your c value should ultimately become minus 6. And you're done. And then, of course, rewrite the equation in full, because that's what it wants. We can say, therefore, the function of x is going to be x to the power of 2.5 plus 4x to the power of 0.5 minus 5x minus 6. And we're done. And you don't have to put that star. That star means done. Alright, so since we've done the hard bit, let's try part B now. Okay. So B is saying, find the equation of the tangent to C, so the tangent to the curve. A tangent is a straight line, by the way, at the point P, which is at 414. Giving your answer in the general y equals mx plus c form, where m and c are constants. Okay, let's have a look at that then, yeah? So one thing to note, every time you find a tangent, we need to firstly find a gradient. So tangent is just a straight line, and just imagine this is the curve C or something. It looks a bit like that, or it could be something different. This is the point P, because that's what they have in common. So every time we have a straight line, it always takes the form of y equals mx plus c, where m is the gradient and c is the y-intercept. C is easy to calculate, and it's not the same c as the previous question. Now to find m, literally we have the gradient equation right here. All we have to do is literally plug in the value of the coordinate we're interested in. So we know that at point P, x is 4, right? So at P, x equals 4. So we're going to plug in 4 into this gradient expression. So we're going to say, right, at point 4, replace all the x values of 4, and when you do that, which I've already done it by the way, you're going to get a total value of 16. So this means that the gradient at x equals 4 is 16. So that's one thing done. So we can say now that y equals mx plus c becomes y equals 16x plus c. Now, how do we get c? Well, again, we know that we're using point P as a reference. And if you recall, point P was what again? Was 414. So now just plug in your coordinates. So replacing x and y 4 and 14, you're going to get over here, which is 14 equals 16 times 4 plus c. And then just rearrange this in the calculator, work this out, and then in the calculator, 14 minus your answer, you're going to get a c value of minus 50. And we're done. It's literally as simple as that. So we can say, therefore, the general equation is going to be y equals, so just replace m and c, y equals 16x minus 50. And we're done. So in this question, solutions based entirely on graphical or numerical methods are not acceptable. Well, so what does this tell us? This means that we cannot put this equation in the calculator and get some results for x, because this would defeat the purpose of what we're trying to do here. So we have to do this using a written method, yeah? So unfortunately, the only thing you can put in your calculator is literally subtracting a few things, but you can't actually solve this. So let's have a look now. 1. Solve for the following range for x, this equation here, giving your answers in degrees to 1 dp. Right, one more thing I also want to add. Every time you got a sine or cos or whatever, and you got a really weird equation inside the angle bit, always replace it with y or another letter. So in this case, we now have 5 sine y plus 2 equals 0. Okay, so this doesn't look as bad as previous. Now, what do we do from here? Well, let's go ahead and find the value of sine y, yeah? So what we could do is subtract 2 across and divide by 5. We're going to have an equation which is sine y equals minus 2 over 5. Okay, oops. So minus 2 over 5. Now, this one looks straightforward. To find the value y, we're just going to sine inverse, yeah? So sine inversing this, you should get minus 23.6 degrees. Now, there's a problem here. Notice how this equation here, when you convert it back to x, doesn't fit within the usual range, yeah? And notice how the value is negative. Well, this is where we're going to use something known as the cast diagram, yeah? So let's try this out. So cast diagram means you're going to put CAST, where C, S, and T is cosine and tan, and A means all. Now, because our result is negative, usually if it was positive, we'd use S for sine and A. So A is always used for positive results. Because we've got negative results, we're not going to use sine or A. We're going to use C and T. Now, let's go ahead and fill this up with some values, yeah? So it tells us that the angle is minus 23.6. We always start from here, so this is our origin. So we're going to go down by 23.6 degrees. And because we're dealing with tan, we're also going to write 23.6 degrees. Okay? Now, from here, we can actually work out the positive values of y. So let's do it. So starting from here, we're just going to draw a nice curve smashing into here. And we'll draw another one going all the way around, hitting this line. So this means that we're going to travel, for the first one, 180 across plus 23.6, or 180 plus 23.6. So this is solutions for y, yeah? And we're going to have another solution which is almost a full circle, so almost 360, but it's 23.6 less. So it'll be 360 minus 23.6. And these results are going to give us exactly 203.6 and 271.4 each. Okay, so we're actually pretty much done here. Now, just remember, this is the values for y, yeah? And we said here, let y equal x plus 65. Okay, so let me recap, y equals x plus 65. So therefore, x is going to be y minus 65. So what we're going to do here, to get x values, we're going to subtract both of these now by 65. And doing so, you're finally going to get 138.6 degrees and 271.4 degrees. And that's it, guys. You've literally got every value in the range for part 1. Okay, part 2. So now we need to find for this new range all the solutions for this equation, giving you answers now in radians to 3 fixed. Okay, so same rule applies, yeah? So first things first, let's switch our calculator from degree to radian mode, yeah? And we won't make that mistake. And by the way, guys, 2 pi is equal to 360 degrees as well. So let's do this. Now, in order to solve an equation like this to find solutions, we have to always solve in either sines or coses or tans. not when they're mixed up like sine and cos. Now, the only way to get them all in the same form is by just recalling some identities, yeah? So we have two identities we need to try and memorize. The first one is the sine squared plus cos squared theta equal to 1. So this is when you have squared equations, yeah? The second identity would be tan theta equals sine theta over cos theta. Now just looking back at what we have, we ain't got no tan. So we're not going to use this one, so that's for sure. The first identity is good. Why? Is because we can rewrite the sine squared expression in terms of cos squared, and that's it. Then we have an equation in terms of cos. So let's try it out, yeah? So what we could do, let's go ahead and let sine squared be the subject, yeah? So subtracting cos squared across, we're going to have something like this. 1 minus cos squared theta equals sine squared theta. So replacing this sine squared with 1 minus cos squared, our new equation is going to look like this. So 12 times, 1 minus cos squared theta. What do we have now? Plus cos theta equals 6. Plus cos theta equals 6. All right. So let's see what's next. So now let's go ahead and expand the bracket. We're going to have 12 minus 12 times cos squared theta plus cos theta equals 6. So now let's go ahead and tidy up this expression, yeah? And by the way, guys, I don't know if you noticed it, but we have a squared expression, a regular expression, and some numbers. So this is going to be a quadratic equation, yeah? So this is the form we want. And when we have a quadratic equation, this means we're going to get two solutions for cos theta. So just think of the cos theta as x, okay? That's literally the best way to think about it. Now, yeah, so let's try and simplify this law, yeah? So we're going to minus 6 across. So we're going to have 6 minus 12 cos squared theta plus cos theta equals 0. Good. And I like to make my squared expressions first. So I'm going to move everything to the right, starting with 12 cos squared, yeah? So we're going to have 12 cos squared theta minus cos theta, and then minus 6 across, minus 6. And it should now be equal to 0 again. That's it. So how do we solve this one? Well, again, this is a quadratic equation. So let's use a quadratic formula. So the quadratic formula is a bit like this, yes? We're going to say, all right, cos theta under the quadratic formula is going to equal minus b plus minus square root of b squared minus 4ac over 2a. All right, where a is the value in front of cos squared, so 12, b is the middle one, minus 1, and c is minus 6. And then when you put this in a calculator, I'm not gonna do this here because you just substitute in. You should get two solutions, yeah? So with the plus and minus result, you'll get either minus 2/3 or what did I also get? 3/4. Okay, so I checked this with the solution anyway, guys, and it all lines up nicely. So when you get this result, now we can finally solve this problem, yeah? So we're almost done, yeah? The 6 mark is almost done. So now all we're going to do is inverse both of them, yeah? So if you inverse the first one, cos inverse minus 2/3 in radians, you should get an angle of 2.30 radians. Or if you cos inverse 3/4, you're going to get an angle of 0.723. So both of these need to be 3 sig figs, yeah? Now, we have to ask ourselves, is there any more solutions for both of them? Well, we're going to use a cast diagram. So let's just do a cast for this one and a cast for that one, where we have CAST, again, CAST. Because we're working with cos and it's positive results, we're going to use the C's, and we're going to use the A because A only works with positive values, with positive outcomes, yeah? And then we just labeled the angles. So on this side, we're going to have an angle of 2.30, and again 2.30. On the right side, we're going to have the angles of 0.723 and 0.723. And then now we're going to finally solve this here. So we always start from the origin. So this is the origin here. We're going to just stretch the angle across, so it's going to go hitting this line, but we got that already, it's 230. Our second one's going to go all the way around and hit this line here, which is almost a full circle. And remember, a full circle is 360 degrees or 2 pi. So our other result is also going to be 2 pi minus 2.30. And again, same thing applies to the right side. We're going to have 2 pi minus 0.723. So same thing applies, yeah? And then that's it. just put this in your calculator and you're going to have two results. The first one being 3.98 and the second one being 5.56. And then collect all your solutions. So you say, therefore, our four solutions is 2.30, this one, that one, and that one. Okay, number 13. So the point A lies on circle C with center O, which is the origin, and radius R. Find the exact value of R. Okay, so very straightforward, to the point. So we're dealing with a circle, right? For these kind of questions, and I'm going to involve A and part B, which is find the equation of a circle. The best thing you should do is always write down the equation of a circle first, the general form. So the general form is always x minus a all squared plus y minus b all squared equals the radius squared, where a and b are the center of the circle, yeah? Center of circle C. Now, let's have a look. So what do we know about this circle? Well, first things first, we know there's a point that lies on that circle. So x is 9 and b is minus 13. And then the origin, the center of the circle is the origin. So a and b must be 0. So let's just update this equation, yeah? I'm just going to change a and b to 0. So in that case, you're going to have x minus 0 squared, which is x squared, plus y squared equals the radius squared. So for part A, find the exact value of R. Let's plug in point A into this equation, yeah? So A. So we say at point A, we're going to now have x, which is 9, and b, which is minus 13. X, which is 9 squared, plus y, which is minus 13 squared. And it's now going to equal... what's that going to equal? And that's going to equal R squared. So basically, to solve R, literally put this in your calculator and then square root to find R, and your answer should be 5 root 10. Yeah, that's it. Straightforward. And for B, it follows on. Find the equation of a circle. So we have equation of circle is right here. R is 5 root 10. If you square it, your equation is now going to be x squared plus y squared equals 5 root 10 squared. I think it's 250. Yep, 250. And that's it. That's A and B done. Okay, next two parts. So a straight line through point A has equation 2y plus 3x equals k. All right, where k is a constant. Okay, so this is 1 mark. Find the value of k. All right, this is easy. So you got A, which passes through this point, and that equals k. Well, all you got to do is literally substitute the value of A into this equation. So replacing x with 9 and y with minus 13, you should get 2 times minus 13 plus 3 times the x, which is 9, equals k. Putting this in your calculator, you're done. You should get a solution of 1. So k equals 1. This straight line now cuts the circle again at point B. Okay, so remember, in the beginning, it cut the straight line cut through point A. And because it's a circle, that only makes logical sense. Imagine this was a circle and this is your straight line. Okay, you know, let's not do that. So you got a center, or ignore the center. It cuts at one point A, which we already know, and it also cuts at the other side, which is B. It could be a different shape, but this is just an example. So our question is now, how can we relate the line and the curve together, the line and circle together? Well, when something passes through another equation, we use simultaneous equation. So that's how it is. So we're going to match them together. So let's rewrite the equation of a circle here. It was x squared plus y squared equals 250. And the equation of a line, which we just obtained, which was 2y plus 3x equals 1. Okay, so now all you want to do is literally put this into the circle equation. So what I would do is, let's say, make y the subject. So from here, to make y the subject, I could minus 3x across and divide by 2. This can give us y equals 1 over 2 minus 3x over 2. Nice and easy. And now I'm going to substitute this into the first equation. So let me just go down a bit. So this is going to give us x squared plus bracket half minus 3x over 2 all squared equals 250. Okay, so now this is where the long thing happens, yeah? So we're going to try and carefully expand this, yeah? Just remember, when you got a squared bracket, it means there's 2 brackets, yeah? So just to be clear, it looks a bit like this. X squared plus bracket half minus 3x over 2 times half minus 3x over 2 equals 250. In the end, when you finally evaluate this, you're going to get a quadratic equation, yeah? So let's go ahead and open this up, yeah? So you're going to get x squared plus half times half is a quarter. Half times minus 3x over 2 gives you minus 3x over 4. You're going to get the same thing here, minus 3x over 4. And lastly, minus 3x over 2 times itself will give us a positive 9x squared over 4 equals 250. Now all we have to do is just collect the like terms, yeah? So let's start step by step. So you got x squared plus 9 over 4x squared. I just combined it and called it, so this is like 1x squared plus that. This can give you 3.25x squared. I'm keeping it in decimal form, yeah? Now for the x terms, you got minus 3x over 4, minus 3x over 4. In the calculator, this will give you minus 6 over 4, will give you 1.5x. And lastly, you got a quarter and you got 250 on the side. Let's make it equal to 0, yeah? So we're going to subtract 250 across, so it goes on the left. And you should get minus 249.75. You might get something similar or, you know, like smaller. If it's proportion the same, then it's all good. But at this stage, we're going to keep it as it is, yeah? So now what we're going to do to find the value of x, as this is a quadratic equation, we have to use a quadratic formula. So we're going to have x equals minus b plus minus the square root of b squared minus 4ac. You probably notice that we use this formula a lot. And that's actually true. Because you've got a calculator, you can easily solve this with no problem. Where a equals 3.25, b is minus 1.5, and c is minus 249.75. When you put this in a calculator, please use brackets for every letter. Like for instance, for minus b, I would write minus bracket minus 1.5. There's no point taking a risk, even if you know it's positive. Your calculator will instantly like recognize it, yeah? But anyway, when you do this, you should get two results. The first one, which is trivial, you're going to get x equals 9 when you plus it. And that matches the coordinate of a. Because if you remember, at point A, we know the x coordinate is 9. So when you plug in 9 into any equation, into the circle of the curve, you can end up with y equals minus 13, which is at point A. Now, if you put the negative value, you're going to get x equals this kind of weird fraction, minus 111 over 13. And when you plug this into any equation you got, so in this case, let's see, I decided to plug into here. You could also plug into here, but then you have to make y the subject, which is unnecessary. So replacing x with that fraction we just got, and you should definitely get something that says, let's see, what was that, plus 173 over 13. I want you guys to check if this one's the same, yeah? I'm pretty sure it is, but have a look and let me know, guys, yeah? So figure 2 shows a sketch of the curve C1 with equation y equals fx, where fx is defined by this. So it's a mixture of a quadratic times a linear, so this ultimately makes a cubic. And looking at the shape of this is a cubic graph, okay? Where it cuts at minus half and it bounces off 2, so meaning there's a repeated root, so there's 2 roots here. That's why they squared this bracket. Okay, and you also got a turning point which occurs at point P. And again, this is also known as a turning point here. So when you have a turning point, we usually find the coordinates by using a gradient equation. We usually use differentiation, where we set dy over dx to 0. When you solve this equation, you find the value x. One of them is obviously going to give you a 2, and the other one will give you another x value to find p. But anyway, let's go ahead and look at part A now. Okay, so there is a maximum turning point at the point marked P. A. Use the first derivative of fx to find the exact coordinates of the turning point P. Okay, straightforward. So literally walking you through here. So here's our fx function. So what you should do is actually expand this first. So let's go ahead and expand it, yeah? So I'm going to rewrite this one as fx equals x minus 2, because there's 2 of them, x minus 2 and then 2x plus 1. I'm going to go ahead and open up the right 2 brackets first, yeah? So you got x minus 2, so you got x times 2x is 2x squared, x times 1 is 1x, minus 2 times 2x is minus 4x, combining is minus 3x, minus 2 and 1 makes minus 2. Now, I'm going to open up the first with the second again. So I'm going to times everything here by the first term, which is x. So x times everything will give us 2x cubed minus 3x squared minus 2x. And now I'm going to times again everything over here by minus 2. So you can get minus 4x squared plus 6x plus 4. A little key note, guys, yeah? When you want to expand a quadratic with what's it called, linear, it's good to line up the powers, yeah? Because this just makes it easy to collect. So now collecting things, yeah, we got 2x cubed on its own, minus 3 minus 4 is minus 7x squared, minus 2 and 6 is plus 4x, I'll delete after, and plus 4. So here's our equation now, yeah? So therefore, just making it clear over here, we're left with fx equals 2x cubed minus 7x squared plus 4x plus 4. Okay, so now just reviewing the question, they want us to find the first derivative of fx, yep? So doing so, by the way, this is the same as dy dx, yeah? And this is also known as, again, the gradient equation, which is what we need to find the gradient and the turning points. So differentiating this, the rule is that you drop the power and subtract by 1. So dropping 3 down, 3 times 2 is 6, subtracting the power by 1 is 2, rinse and repeat. And if you left it just an x, it vanishes. If you got a constant, that whole thing goes. So that's done. Now, to actually solve this, it says here, and the note I put over here was that the gradient equation is set to 0. When you solve this equation, this means that the gradient is flat. When it's flat, it's we set to 0. So we have to set this equation to 0 and solve this quadratic. Now this is easy. You just use the quadratic formula. So I'm going to lay out for you guys. So the quadratic formula is x equals minus b plus minus square root of b squared minus 4ac all over 2a, where, according to our quadratic above, a equals 6, b equals minus 14, and c equals plus 4. Right, so again, when you put this into the quadratic formula, always wrap the letters in a bracket. So minus 14 here would be minus 14 or bracket. Well, it becomes positive here and so on. So when you guys carefully do it, you should get 2 results. One of them being a third, or one of them being 2. Now, as expected, one of the solutions has to be 2 because, according to the graph, you have 2 turning points, and one of them is 2. So that's correct, meaning this one must be a third. So x over here cuts at a third, yep? So we found the x coordinate of p. How to get the y coordinate? Well, we can plug this into any equation which describes this curve. And the curve is described by this equation here. So replacing all the x values with a third, we're going to get a third minus 2 all squared, and 2 times the third plus 1. Putting this in your calculator, and you should get a final result of, so point P would be a third, comma, 125 by 27. And that's it, guys, you're done. And this is, in my opinion, in easy 7 marks. Okay, this is easy marks to bag. Okay, part B. So before part B, a second curve C2 has the equation y equals fx plus 1, where now x has been replaced with x plus 1. Okay, so what that actually means is that you literally replace these x values with x plus 1. And what it means graphically, if it's a plus something in the bracket, this means you shift all the x values by 1 to the left. So in other words, it's going this direction. It sounds weird. You'd think it moves to the right because it's positive, but what that means is that everything is shifted in reverse. Okay, if it was x minus 1, then you shift it to the right. So the values of x move along this way. So 2 would become 3, minus half it becomes plus half, and so on. I should really tidy this up a bit. Okay, so let's go ahead and solve part B. So write down an equation of the curve C2. You may leave your equation in factorized form. That's really kind of them. So what we're going to do, replace this x with x plus 1, yeah? So we can say this one is equal to, bracket, replaces with x plus 1, so you got x plus 1, and then, of course, minus 2 squared. Now this one is 2x So replace over 2, a little bracket, x plus 1 plus 1. Now all you want to do, guys, is literally just tidy up the inside, yeah? So this will be tidied up 2. So 1 minus 2 is just, what's it called? Minus 1. So x minus 1 squared. So expanding this carefully, you got 2x plus 2 add 1. So it's 2x plus 3. Okay, and that checks out. C. Use your answer to part B to find the coordinates of the point where C2 meets the y-axis. Okay, so when let's have a look. So when C2 meets the y-axis, and that's actually, you don't even need a graph for this. When something meets one of the axes, this means that the other coordinate is 0. So if you meet the y, this implies x coordinate must be 0, because that's the only way for it to hit some curve, hit the y-axis. X should be at the origin. So when x equals 0, you just plug into this equation here. So you're going to get y equals 0 minus 1 squared, and then 2 times 0, which is 0 plus 3. So this is your final result. So put this in the calculator, you should get a y coordinate of 3. So therefore, the coordinates of the points where curve C2 meets the y-axis is just simply x is 0 and y is 3. Oof, this question is quite chill, isn't it? So next one, D. Write down the coordinates of the 2 turning points of curve C. Oof, literally the same as this one, yeah? But we just explained that the curve, because it's x plus 1, it shifts to the left by 1. So this coordinate point, because there's 2, it shifts, you subtract 1, so it shifts to 1. So we've done one of them. So actually, let's put it here for a second, yeah? So here was our, this was our previous previous points. And by the way, the other one over here, 2, this was 2, 0, because again, it hits the x-axis and it hasn't gone up or down. So our 2 turning points was 2, 0. Let's call this M for max, yeah? This now, so for part D, the M coordinate now becomes 1, 0, because it shifts to the left by 1. And P now becomes, so they give him a little dash. So a third, subtracted by 1 gives you minus, mental maths, 2/3. And again, the y coordinates don't change because you ain't shifting the y, you're shifting the x. And that's all. That's this part done. Yep, so y is the same, x is that. Let's go back to the last bit now. So E. Sketch the curve C2. Whew, with the equation that, so basically sketch that C2 that we've been working on, given the coordinates of the points where the curve crosses or touches the x-axis. Notice how they don't care about the y-axis here, yeah? So you don't even need to worry where it hits the y, but that's not too hard to find. So for the sake of convenience here, we're going to go ahead and try and sketch it and see how it looks compared to the old graph. It's better to draw on the same graph and then update also. For you guys, oh great, PC and battery saver mode. No worries. So everything shifts to the left by 1, so minus a half. Over here it becomes minus 3 over 2 because that's what happens when you take away 1. 2 here is now at 1. And a P coordinate here, so what was the P value? It was a third. It now goes to the left at minus 2/3, which is around here. It's less than minus a half, by the way, yeah? So the graph is now going to look something like, hold on, change color pen. Here, hits that P, the new P here, and then dips down to 1 here, and then shifts upwards. So that's it. This would be your y equals fx plus 1. Now, just to be clear, you don't do on the same graph. You're gonna probably draw it. Where is the graph? So you probably draw it. Yeah, you'll draw it around here. Okay. But anyway, guys, that's it. That's 14 done. I hope this helped, and I'll see you guys at number 15. Okay, number 15. So a design for a logo consists of 2 finite regions, R1 here and R2 there, shown above. The region R1 is bounded by straight line L and a curve C. The region R2 is bounded by the straight line L and curve C with equation x equals 5. So you got a third line up here, yep. The line L1 has this and curve C has that. Cool. Given that the line L meets the curve C at points, what's that, minus 222 and 470, use integration to find, I love what they told me to do, the area of the larger of low region and the exact value of the total area. Alright, cool. Let's try our best. So we'll start with A. Now, one thing to note here, yeah? So we've read everything. The only way to calculate this region 1 is to think about what kind of shape we've got here. Well, when you use integration, the purpose of integration is that it calculates area under the curve. So we can see we've got a curve here. Yeah? So if we just draw a dotted line here for a second, yeah, to see how long the curve extends. So just draw a straight line going down from the 2 points. So this point here is just -2, and this point here is 4. Calculating the area under the curve will calculate this white region here, all the way up to here. Yep. So that's the area we would find. Let's just give this a name for a second. Yeah. So this area here is going to be called I1. Yeah, just I. So the integrating area. Now, another thing we can also see is that this shape, which covers from -2 to +4, you can see some sort of trapezium shape. Yeah. So a trapezium is formed. So let me just line that up. So we got from here to here, all the way across here, and following this line. So here's a trapezium where we got two parallel lengths. So these are parallel lengths of look at the y-axis from 0 to 22. So it's 22, length of 70, and we got a width now from -2 to 4 of 6. So effectively, the way to calculate the region 1, so if we had to do like a formula, we could say that the region 1 is composed of finding the difference from the area of the trapezium and the purple region, which I called I1. So that's it, guys. If you can work out this equation here, you found area. You found the region 1. So let's start with the easy one. What is the area of the trapezium? So we could say that area of trapezium AT is literally the average between the two parallel lengths. So the average, which is half of, between 22 and 70, 22 plus 70. So this is the average between the two lengths times the other length, so the perpendicular length, so the width, which is 6. Okay, so that's one thing. Doing this in your calculator, you should get 276. So that's the area of the whole shape, the whole trapezium. Now, as for the purple region, the I1, well, we need to use integration and calculate the limits between -2 and 4. So let's do it here. So for part A, we can call this I1. We want to integrate from the two bounded limits from -2 and 4, -2 and 4 of the curve, okay, with respect to x. Now the curve, we know the formula is for the curve. It's right here. So 4x squared plus 6. So what we do, we just update this curve equation, right? 4x squared plus 6 dx. I use a bracket here because it's just to indicate that you're integrating all of this respect to x. Okay. Now integrating this one is not too bad. The rule is that you firstly just increase the power by 1, so it'll be 4x cubed and divided by its power. Same. If there's just a constant, you just do 6 and stick an x in. Okay. And because you've got limits, put some nice square brackets and put -2 and 4 here. So this implies that you can replace the x values firstly with 4, find the solution that then replace it with -2, and then find the difference. So ultimately, replacing the x values of 4 in your calculator, you should get something like 328 by 3, and then subtract, and then replacing what's it called, the x values of -2, you should get -68 by 3. And just computing this, which isn't too bad, okay, it's not, approximately is equal, you should get 132. Now that kind of looks legit, because if you look at the values, we got 276 for the whole trapezium, and to be honest, this region, I don't know which side is actually bigger, but as long as your I1 as long as your area under the curve is smaller than your actual trapezium, then it looks alright. So now we can say, alright, so therefore R1 must be the difference between 276 and 132. So just write it down to show you guys. 276 minus 132. Calculating this, and you should get 144 units squared. It's good to give it a name, yeah? And now for part B, we need to find the exact value of the total area of the two shaded regions. So R1 plus R2. Well, we got R1. Let's try and work out R2 then. So looking at R2 carefully, it's kind of similar actually to R1. It's more or less the same thing. The only difference now is that the limits are between 4 and this new line 5. So x equals 5. So far, what kind of shape do we have here? Well, we can see that the curve is flowing from here, yeah? So here's the curve. So when you use integration, you'll find the area under the curve. So it's going to cover the whole region. And now the trapezium is actually here. This is the trapezium. Okay. We have a trapezium here, and we got the area under the curve from the red line downwards. So, now the only problem here is that we're actually missing some information. So let me just delete this part for a second, yeah? We've got a height here. Actually, let me delete the green as well. So we know from the left side of the orange line, there's a height of 70 because it goes up 70. But what is the height of this line? Well, we know that first things first, that this line equation here has an x coordinate of 5 at this point here. So all we do is substitute the value of x equals 5 into that line equation here. This will give us the exact coordinate of this point right here. And once we have the exact coordinate, we can see the actual height of it. So go on. So replacing x with 5 here. If you put x into x equals 5 into this equation, you should come out of a y coordinate of 78. Okay, so that checks out. So this implies that this coordinate here is 5,78, meaning we have a height now of 78 from here to the bottom. So working out the area of trapezium is easy. Okay, so let's just delete this as well. Delete that, delete this. You don't need this anymore. So trapezium, so let's define a formula. We can say to work out the area of R2, the region 2, is going to be a difference from the whole integration. So let's call this I2, which implies that this is the area under the curve using integration, minus that little trapezium area. Okay, so trapezium, we already worked out 80, which is going to be the average between the two parallel sides, so 70 plus 78 times the width. Well, the width is just 1 between 5 and 4, so times by 1. So that's no different. Putting this in your calculator, you should get 74. So the area of trapezium is done. Now all we need to do is work out the area under the curve between 4 and 5. And that's it. So let's do it here. So it's actually going to be similar to part A, in fact. So actually, yeah, so there's not much new things here, is there? So I2 equals the integral from 5 to 4 this time of the same thing as above. So I don't even know why I'm copying this down. It's actually the same. Result is obviously going to be the same. 4x cubed over 3. 4 plus 6x. Difference is the limits, 4 to 5. Well, we know what the result at 0.4 because we just calculated it. It was 328 over 3. Now, but at 0.5, so we do 5 first, replacing x values of 5, you're going to get firstly a result of 590 over 3 minus the result at x equals 4, which was 328 by 3. Okay, so this is just easy subtraction. It reduces to 262 by 3. And now we found I2. So going back to the formula, we said that the region 2 is the difference between I2 and AT. So it'll be 262 over 3 minus 74. So region 2 equals was it 262 over 3 minus 74? That'll give us 40 over 3. Quite small. Yep, makes sense. And that's a small area. So that's it. We found the region 2. So therefore, part B, the exact value of the total area of the two shaded regions. So it'll be R1 plus R2. R1 plus R2, which is going to equal now. So in your calculator, write this down. 40 over 3, which is over here, plus 144. So 144 plus 40 over 3, and it comes down to 472 by 3. Or if you want to write a mixed number, which is not even important, 157 and 1/3. And that's it. And that's, again, units squared. Now the last one is easy, you know, it's too easy. So given that the area of R1, which we have, is 144 over the area R2, so 144 over the area R2, which is 40 by 3, equals K. Find K. Trust me, they didn't even try at this stage. So you just divide these numbers, and well, I got the mark scheme up, and I can't bother to figure it out. The answer is 10.8. And that's it. Question done. So this is 10.8. Anyway, guys, I hope this video helped. Let me know if you got any questions, and other than that, if you guys enjoyed the video, please give me a like, subscribe, and especially share to your friends, you know, because the more my channel gets exposure, the more I can produce good content, and the more that YouTube will help fund my projects as well. And this will help me produce better videos, more past solutions, everything, you guys name it. Anyway, guys, have a nice day, and I'll chat to you guys soon.